Hey everybody, this is Larry. This is day 21st of the October. I'm on Discord. Let me know what you think about today's poem. I should click on it. I just came back from watching the Liberties game. They won! Yay! World champions! Yay! I went to a couple of games this year, so pretty excited. And yeah, it's always good. It's and the Yankees are in the World Series. Hopefully they win too. It's New York has not had a champion in like a long time in like any sport. So it's very good. It's very exciting. I'm very happy today, and I'll be happier hopefully in 2 weeks. But when the Yankees win, or if the Yankees win. My marathon's in 7 days. I am just dealing with the effects of tapering from the training. So today I just did a casual 6-7 miles or something like this. So we'll see how everything goes. Still excited. We'll see how, and today we have a problem to do though, right? That's why we're here. That's why you're here anyway. Well, that's why I'm here too, because, but let me know what y'all are working on. I'm curious, outside of LeetCode, of course. Well, maybe not of course, but yeah, whatever it is fine. And it's also okay if you're only working on LeetCode, because it can be tiring and it could be like it's tough, like there's a lot of things to do, I guess is my point. Anyway, let's take a look. Let's get started. On this Sunday evening, 1593, split a string into the max number of unique substrings. Okay, given a string S, return the max number of unique substrings that can be given, that the given string can be split into. What does that mean? You can split string into any list of non-empty substrings, where the concatenation of the substrings form the original string. However, you must split the substrings such that all of them are unique. A substring is a contiguous sequence of characters within a string. Okay, what does that mean? A, B, so you have this thing. Let me ASCII order it, and then they're splitting it A, B, C, C, and they all have to be unique. Okay. Yeah, the first thing I was going to do is honestly, the first thing I was like, this seems like at best it'll be dynamic programming without looking at the constraints, just because I don't think, I don't know, and some of this is because, and I don't know that there is a dynamic programming, honestly. But and maybe we can check for it later. But if there is a solution that is non-exponential, then it would be dynamic programming, or like pseudo polynomial or something like this, right? Or something maybe on the size of the alphabet, for example, the number of digits or number of the cardinality of the set or something. And the reason is because there's just so many possible decisions, right? And when there's a lot of decisions, you only really have a couple of directions you want to go. Maybe it's greedy, and greedy is, you just get a little bit, it's just tough to imagine there's a greedy for this one, because everything affects everything else. And then the other one is dynamic programming, right? And you can, there is a dynamic programming for this one actually, I think, but wait, is it? No, no, not even. I was gonna say maybe there's a bitwise or bitmask, bitmask dynamic programming, but no, those are not states, right? Because the thing is that the thing is that you cannot just split it by some sub. Well, I mean, I think there are no. The thing is that the sub-problems are not alike. I think that's the thing, right? So that's why my second instinct is that I don't think there's a dynamic programming, or at least not the trivial E. It's not that trivial, but trivial by comparison, bitmask dynamic programming. And then, of course, all that being said, and I saw n and the 16 is like, okay, well, if n is 16, then that means that n times 2 to the 16, or even n squared times 2 to the 16, or 16 squared times 2 to the 16 is fast enough. And that is what we're going to do. One of those. Yeah. I think that's pretty much it. I mean, and of course, a lot of what I said, it's a little bit, theory thing. It's not like hard math, but this is also where practice gets you, right? If you practice a lot, you just have some intuitions about these things. Maybe it's never, like nothing's gonna be 100% because, well, you didn't prove it, right? But with practice, you kind of just get the feeling and the texture of these problems and able to at least make an educated guess. And sometimes you're gonna miss anyway, but that's a way to think about it. And of course, the way that you want to do this, assuming that this is one of the NP problems, either hard or complete, is of course, if you do want to make that proof, you have to what's the word? I want to say convert it to NP, to an existing, but there's a more rigorous mathematical word for it, but I'm blanking out right now. But basically, you want to rephrase the problem, if you will, as an existing NP problem that you do know, like maybe like some vertex cover or something like this, so that you can prove that this is NP. And when you know that it is an NP, one of the NPs, well, then there's nothing you can do other than brute force, or it comes down, there are a lot of just general things, right? Like branch and bound, or but that comes to heuristics and doesn't change the complexity. Or of course, if complexity really matters to you, then you come to like approximation algorithms, which is of course beyond the scope of this video and LeetCode and stuff like this in general. But yeah, though I do know that Codeforces, I don't know, sometimes have competitive programming problems kind of like that. No, maybe not. Maybe Codeforces is still just binary. I think what was it? DMOJ, DM Online Judge. I don't know what the DM stands for actually. They made the site a lot faster. What does DM stand for? Unclear. I'm reading the about page and it's not super clear to me. So, In any case, my point is that then you can use approximation algorithms there. Okay, so all that said, let's get started. I mean, here we're just going to write brute force in as silly as possible, say. And you can really think about this in a way as a take no take kind of thing as well, right? Of course, you're not going to put a memorization on it, but you can do it, and maybe. But and then you just try to think about the states, and the states is the set that you've already, the set of words you've already seen. So maybe we have a scene, we have the index of the number that we're processing, and maybe also like the starting index, right, of the current word that you're ending with. But maybe we don't even need that actually, because we can write. So yeah, there are two ways to write this, and they're equivalent, right? One is the take no take, as I always say now, because I don't know, I was inspired by chess, and now I've seen other people use this take notation. I would like to think I contribute to it, but I don't know if that's actually true. Maybe I stole it from someone, subconsciously or something. But in any case, yeah, so you have to take per character, right? So you can do it this way, and of course, if you're going to write it this way, then you have to keep track of the starting index of the current word. But you can also say, always you can always write it another way, which maybe for this problem I find a little bit easier, but this is the thing, right? If you have multiple ways of writing it, if you have multiple tools in your head, you can write it the way that is easier to write, right? And it's always take a word at a time. And for that means that you can do a for loop in here, right? So for variable names are tough. So at index, so here we want to say scene is the set of substrings with scene, right? That we cannot repeat. And index is the current index we're up to. though technically speaking, you probably can calculate this index from scene, but it's just easier to write instead of calculating it every time. And the reason why I say that is because you can because everything in scene is unique. You can just sum up all the length of the characters to recalculate index, but why bother, right? You're not even memorizing it. But anyway, so take a word at a time. Right, so then now you take a second index. I'm just by n index maybe, I don't know, in range starting from index all the way to n. And basically what you want is take index to n index as the current word, right? And so then now maybe I'll just write it out, and I have s index to n index plus 1, so that you be inclusive, right? And then we could do scene dot add. Well, I have to check first. So if current word in scene, then we just kind of keep going. Otherwise, we add current word. We do a recursion on scene, and now we want n index plus 1. And of course, we actually should write that if index. But I think we don't need to, because if it's n, then it doesn't. This loop doesn't tick anyway. But I always like to be explicit because I think that's fine. Then we can just return. Yeah, we could just. I mean, you could write it both ways, right? I'm just thinking of. Oh wait, it's maximally, right? What was the maximum number of unique substrings? So that means that this is going to be. Well, this is going to be 0. Here we did a recursion, so then, oops, what did I press? We did this thing plus 1, right? So then now we can take best is equal to 0, best is equal to max best, so we could keep on finding the best thing. And then now we have to remove back the word because, you know, this is just the recursion, how the recursion works. And that's pretty much it. And then now we can just recurse a new set and the index of 0. And I think we're okay here. I'll go over the complexity real quick, but let me quicker submit. Hopefully I didn't do anything too silly. Huh, it's much what did I do last time? That is so slow. Oh, I did it the bitmask way. Shouldn't be that much slower though. Huh. I mean, I was also debating it this way, which is also fine. But yeah, the way that you kind of think about how to analyzing this, because there's a recursion and there's a for loop here, it's a little bit tricky for sure, honestly, but you can amortize everything out. And if you amortize everything out, then you can see that you know, you can see that if you have something like this, then the idea is just that, you know, if you think about the spaces in between every character, at every space, then you can make it so that you add a divider here, and also everything in the previous and in the future, right? So even though this is not the usual tick no tick, you can see that every space in between the characters will get filled up in a binary kind of way, and all of this depends on all the other ones on the left and to the right. So that's why it's kind of like multiplicative in that way, right? So that's gonna be 2 to the n, and in here we do have an extra n index as a result, or O of n thing here, and also add is O of n. I mean, it's O of 1 to scene, but O of n for the current word, right? Because you have to parse the word to get a hash or something like this. Though maybe, I don't know. I guess that's a little bit implementation dependent. And if you really want to, I suppose you can reduce this to O of 1 by kind of just by pre-calculating a rolling hash here and then just adding the hash or something. But we won't go into that too deeply. But as a result, it actually makes it. I believe it is n to square times 2 to the n. Technically n minus 1 if you want to be precise, and maybe it's worth being precise because n is only 16, so the difference between 15 and 16 is quite a bit. But yeah, that's pretty much it. That's all I have for this one. Yeah, is that the answer? That I'm just curious whether I'm missing like an obvious maybe it's only n times 2 to the n. I thought it would be n squared though. Maybe it gets amortized out. I don't know. I think it's. I think these things sometimes are a little bit tricky. But maybe it's only n to the. Why am I thinking of n squared times 2 to the n? Not sure actually. But that's all I have for today, though. That's all I have for this one. Yeah. Let me know what you think about this. And I would say again, go Liberty, go Liberty, go New York, go Yankees. Stay good, stay healthy, to good mental health. I'll see you out later and take care. Bye bye.